Okay, this is section 9.2 over ellipse. And we're going to be writing the standard form of an ellipse. And we should remember that when we were folding our conic section, an ellipse is a set of all points in a plane, the sum whose distance is from two distinct fixed points, which we're going to call the foci. It's constant. So for example, okay, um, if this is the point xy, this distance 1 and this distance 2, when I add those together, it's always constant, no matter which point on this ellipse that I pick. Okay, so if I pick this point, this distance here, this distance here is still going to be the same. It's going to be constant. All right. When we're talking about an ellipse, we have what we call major and minor axes. Okay, the long, and we also have vertices. Okay, these would be my vertices here and here. This would be my vertices on my minor axis. Your minor axis will be the shorter one. Your major axis will be your longest. Um, and that just kind of makes sense. I have the center. Um, and then we also have what we call our focus or our foci. So, and the thing is, our foci, sometimes I say foci, I don't know, foci, um, they are equal distance from the center. Okay, so if my center here, my two foci will be equal distance from that point. All right, so let's look at the standard form of an ellipse. Okay, the standard form of the equation of an ellipse with center HK and major and minor axes of lengths 2A and 2B. Okay, so our major axis will be 2A and our minor axis will be 2B. A in the equation of ellipse, my A number on the bottom is always my largest number. Okay, so when I have an ellipse and the major axis is horizontal, that means my ellipse is longest on the horizontal axis. Okay, that's a major axis. Here's the equation. And my center of that ellipse will always be HK. All right. Now, when I have a major axis, when the major axis is vertical, okay, that means it's going to look something like that. That's assuming my center is at 0, 0. And you see that everything stays the same except for my A and my B. My A is always my largest number, so that's always going to go under whatever axis is the major axis. So if my x-axis is the major axis, my largest number will be on the bottom of the axis. If my vertical axis or my y-axis is the major axis, my A will always be underneath my y values. Okay, and I'll kind of show you what that means, what it looks like. And then the foci lie on the major axis, so my two focus points will always lie on the major axis, C units from the center. And here's how we find C. Here are our A's and B's underneath, and we find C by C squared equals A squared minus B squared, or C equals the square root of those. All right, and if the center is at 0, 0, the equation takes one of these forms, again, depending on which axis is the major axis. All right, so remember to find C. C is how many units from the center, okay, and that's how we find the focus points, okay, or the foci. It's C units from the center. All right, so let's do example 1. Example 1, find the standard form of the equation of the ellipse having a foci at 0, 1 and 4, 1 and a major horizontal axis of length 6. All right, so it's going to help us if we kind of get a picture. So I have a point at 0, 1 and a point at 4, 1. So 1, 2, 3, 4, 1, 2, 3. All right, so I'm just going to plot these points. I have the point 0, 1 and the point 4, 1. Okay, now these are not the I lost my word. This is not the vertices. Couldn't think of it. These are not the vertices of my ellipse. This is the focus points. And then my foci always lie inside the ellipse. All right. But it says my major horizontal axis. So I know it's going to look something, these points are going to go this way. Okay. Now, the first thing that we want to do, okay, is let's find the center of this ellipse. Well, if I know where my two foci are, I know that the center is right between those 2 points. So can you see that if those are my two foci, my center has to be right between them? Okay, so my center has to be the point 2, 1. Do you see that? And so that's going to help me write my equation. Okay, so I already know I have a major horizontal axis of length 6. All right, so let's look. I have a major horizontal axis, so this is the equation that it's going to look like. All right, and notice that an ellipse is always set equal to 1. So I know that my center is 2, 1. That's my H and that's my K. All right, so the first thing I know I can write is x minus 2 quantity squared plus y minus 1 quantity squared equals 1. And then I just have to figure out what numbers are going to go on the bottom. Well, we can find A because it told us that the horizontal length is 6. And in our notes, it says that 2A is the length of my major axis. So I know that 2A has to equal 6. That means A is equal to 3. So I know that A is going to go underneath my X's because it's a horizontal major axis. And so my largest number, which is always A, goes underneath the X. Okay, now I can find out what B is. And the way I can find out what B is I know what C is. Okay, and remember, to find out my A and B, it's C squared equals A squared minus B squared. Well, I know what my A was. It was 3. Now I need to find out what B is. Well, it didn't tell us what C is, but we can find out what C is. C is always the distance between my center and my 2 focus points. Okay, so the distance, 1, 2, is 2. So C has to be 2. So 2 squared minus B squared. So 4 equals 9 minus B squared. That means B squared equals 9 minus 4. So B equals the square root of 5. So that's going to go here, the square root of 5 squared. All right. So now I'm just going to simplify that. X minus 2 quantity squared over 9 plus y minus 1 quantity squared over 5 equals 1. That's the standard form of that ellipse. Okay, example 2. Sketch the ellipse given by 4x squared plus y squared equals 36. So first of all, we should automatically recognize that this is not set equal to 1. And it always has to be set equal to 1. So if it's not, we're going to divide by whatever number this is because we want this to be 1. So I'm going to divide everything by 36. So when I simplify this, I get x squared over 9 plus y squared over 36 equals 1. Okay, now we should know just by looking that my center is at 0, 0 because it doesn't have an h or a k. So I know my center is 0, 0. Okay, I know on the x-axis, okay, I'm going to go a distance of 3. And I do that by the square root because I'm taking the square root of this. So I'm going to have a distance of 3 on the x-axis and a distance of 6, because square root of 36, on the y-axis. All right, and it's going to be really ugly. You guys will do so much better because I can't hit my points, but there's the ellipse. Okay, example 3. Sketch the graph of the ellipse, and it gives me this. So here's the problem. It's not in my standard form. Okay, so let's group together our x's and group together our y's. So I have x squared plus my 6x plus my 4y squared minus my 8y, and I'm going to move that 9 over the other side. So we should recognize that we're going to have to complete the square on my x's and my y's. So let's do my x's first. When I complete the square, I take half of 6, which is 3, and square it. So I'm adding 9 to both sides. Now, here's a problem right here. Anytime we complete the square, this first term always has to be a 1 there. So before I do anything else, I need to factor out that 4. Okay, so just to save a step here, I'm going to go ahead and write this as a perfect square trinomial. That's x plus 3 quantity squared plus 4. Now I'm going to complete the square on this. So I have y squared minus 2y. Take half of 2, which is 1, square it, and I add 1 to both sides. But here's the thing. I'm not only just adding 1, it's 4 times 1. So 4 times 1. Now I'm going to rewrite this. X plus 3 quantity squared plus 4, y minus 1 quantity squared equals 4. And now we're almost there. Since this is an ellipse, it always has to be set equal to 1, and it's not. So I'm going to divide everything by 4. So I have x plus 3 quantity squared over 4 plus these 4 cancels, and I have y minus 1 quantity squared equals 1. Okay, so my center is at negative 3, 1. So negative 3, 1 is the center. Okay, and from that, all right, on my x-axis, or not on my x-axis, but parallel to my x-axis, I'm going to go 2 in both directions. So to the right 2, to the left 2. And here, this is a 1 on the bottom. So on my y, vertically, I'm going to go up 1 and down 1. Okay, and those are the vertices of this parabola, of this ellipse. Okay. Example 4. Find the center of the vertices and foci of the ellipse. Okay, so again, I need to group together my x's and group together my y's. And then I'm going to move that 8 over to the other side. So on this one, I'm going to factor out that 4 first, x squared minus 2x. Okay, and then let's go ahead and complete the square on this one. I have y squared plus 4y. Take half of my middle term, so half of 4 is 2, and square it. I'm going to add 4. Right here, I'm going to take half of 2. Half of 2 is 1. Square it, and I add 1 to both sides. But I'm really not adding 1. I'm adding 4 times 1. So 8 plus 4 times 1. I'm going to write this as a perfect square trinomial. And then I'm going to write this as a perfect square trinomial. And that equals 12 plus 4, 16. we always want it set equal to 1, so I'm going to divide everything by 16. So when I simplify, I have x minus 1 quantity squared over 4 plus y plus 2 quantity squared over 16 equals 1. All right, so the first thing I'm going to do is I'm going to write down my center. My center is 1, negative 2. Okay, so I'm going to go ahead and graph that. My center is going to be at 1, negative 2. And then I know, because it helps me to sketch this out, and then I can find my vertices and my foci. So I know I'm going to go on the x-axis, or parallel to the x-axis in the x direction, 2 in both directions, and then 4 for my y's. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I have my center. I can write down my vertices just by looking at the graph. My vertices would be, what is that? 1, 2, it would be 3, negative 2. Oh, when we write our vertices, we're just going to write our major vertices. So our major vertices would be this one right here and this one right here. Does that make sense? So that's going to be the point, what? 1, 2, and the point 1, negative 6. All right. And the only thing left is to find our foci. Okay, we know that our foci have to lie on this line. Okay, and they are equal distance from the center of the circle. So we know what our A is. We know what our B is. Our foci is is C units from the center. Okay, so C squared equals A squared minus B squared. Okay, so I'm looking at this. C squared equals, my A is always my biggest number. Okay, so my A is 4 because the square root of this, it's being squared already. So 16 minus 4, here's my A squared, this is my B squared. So C equals the square root of 16 minus 4, which is 12. So that's going to be plus or minus. When I simplify that, that's 4 times 3. So that's 2 square root of 3. So my foci is going to be from this point, from the center, it's going to be that point. So it's going to be to the right 1. And then plus or minus 2 radical 3. It's this distance from the center. So 1 plus or minus 2 square root of 3. Okay, and we'll probably have to do one of those, another one of those again, and that's fine. All right, but at least you kind of see what it looks like.